Let's jump right into this. Today, we are breaking down something truly monumental, the EU-CEM Handbook. We're going to unpack this incredibly dense 200-plus page document because, well, it is quite literally the blueprint. It is the definitive European framework for the future of autonomous vehicles. Okay, so how exactly do we prepare society for robot drivers? It's a massive question, isn't it? I mean, introducing self-driving cars to public roads sounds like an absolute recipe for chaos. Just imagine robot drivers trying to mix it up with totally unpredictable human drivers, pedestrians, bikes. It could be a complete logistical nightmare. But the incredible thing we're looking at today is that we actually have a highly structured solution to prepare society for this exact scenario. But before we get into the how, we need to demystify this core acronym that pops up constantly in the source material, CCAM. It stands for Connected, Cooperative, and Automated Mobility. I know, it sounds super technical, but it really just represents the future of higher automation in road transport. We aren't just talking about some lone, isolated car that can steer itself. No, we are talking about a fully integrated network. A world where vehicles communicate with each other, where they cooperate with city infrastructure, and actually automate the movement of both people and goods. So, here is our roadmap for the explainer today. First, the Automated Mobility Challenge. Second, crafting the master plan. Third, zooming in on the vehicle and human. Fourth, zooming out to the system and society. And finally, reporting for the future. All right, part one, the Automated Mobility Challenge. You see, the push for all this technology didn't just happen overnight. If we go back to 2020, the European Commission laid out what they called their Sustainable and Smart Mobility Strategy. And in it, they set a remarkably bold policy ambition, large-scale CCAM deployment by 2030. 2030, that is practically tomorrow. So to support this massive shift, the European Union's Horizon Europe program funded a huge initiative called the FAME project. Their entire mission was to create this common evaluation methodology, the EU-CEM, to make absolutely sure that when these vehicles finally hit the streets, they're tested under a unified, rigorous framework across Europe. Which brings us to part two, crafting the master plan. The handbook actually lays out 3 distinct chronological phases for applying its guidelines. First up, you have ex-ante impact assessments. Basically, this is the deep preparation phase before deployment, helping us identify any weird, unintended outcomes before a single tire even touches the tarmac. Second, you have ex-post evaluations, which means assessing the impacts of the systems once they are already implemented out in the real world. And third, taking all those evaluations and integrating them right back into the actual design and deployment initiatives. This brilliantly illustrates how the methodology isn't just some final exam you pass once. It's a living tool used before, during, and after a vehicle hits the road to constantly refine how it integrates into our lives. And all of this builds into a really comprehensive analytical framework. The handbook categorizes evaluations into 4 distinct levels. Think of it like a giant ripple effect in a pond. The initial splash in the water, that's the vehicle itself. But the ripples extend outward. The very first ripple hits the human, the person inside or interacting with that vehicle. The next ripple impacts the entire transport system. And the final, widest ripple washes over society as a whole. Now, the really crucial point here is in the numbers. Get this. Out of 18 specific evaluation areas defined by the entire handbook, only 2 are focused exclusively on the vehicle itself. Just 2. The other 16 focus entirely on the human, the system, and society. Think about why this matters for a second. We spend so much time worrying about whether a robot car can see a stop sign, but this European framework recognizes that the real challenges and the real evaluations lie way outside the car. It's all about comprehensive societal planning. Let's look a little closer at part 3, zooming in on the vehicle and human. Summarizing chapters 4.1 and 4.2 of the text, we start to see the true depth of these micro-level impacts. Obviously, on the vehicle side, evaluators have to test technical functioning, the software, the hardware, cybersecurity, as well as driving behavior, meaning vehicle dynamics and how it actually interacts with the environment. But as we move outwards to the human level, the evaluation expands dramatically. Sure, they test the standard user experience, but they also evaluate people mobility. Like, are these new automated options actually affordable and suitable for real people? And perhaps the most fascinating part to me, they measure quality of life. They literally evaluate if autonomous mobility supports an individual's physical, mental, social, and even financial well-being. Now, let's pull the lens way back for part 4, zooming out to the system and society. Because it's great if a single car can steer itself safely, right? But how do thousands of these cars change the entire world around them? This contrast right here beautifully showcases the pure genius of the EU-CEM handbook. It captures both extreme ends of the spectrum simultaneously. On the micro end, at the vehicle level, you've got evaluators actively hunting for a single line of bad code or a tiny cybersecurity vulnerability. But on the macro end, at the society level, they're evaluating spatial land use, the functional livability of our cities, and equity, meaning the actual fairness and inclusivity of these new technologies. It is a breathtakingly wide lens. When we look at that third ripple, the transport system, we see how automated vehicles are going to change the collective heartbeat of a city. The handbook mandates evaluating traffic flow efficiency and collective traffic safety. It also demands a deep analysis of logistics, total transport activity, and the energy and environmental emissions profile of these massive new fleets. It even evaluates accessibility, quite literally the ability for diverse populations to safely and reliably reach their destinations. Now, what's really fascinating about all this is how the handbook prepares us for failure. It isn't just some abstract list of lofty goals. The methodology explicitly maps out strict guidelines and highly detailed tables dedicated solely to avoiding common pitfalls. For example, Guideline 3.20 focuses entirely on data pitfalls. Table 8 warns against driving evaluation errors, and Table 67, that one is entirely dedicated to avoiding equity pitfalls. The researchers knew that testing cutting-edge tech is incredibly messy, so they built a literal troubleshooting guide right into the foundation of the master plan. Which leads us to our final section, Part 5, Reporting for the Future. Chapter 5 of the handbook makes it crystal clear. Evaluating all of this in a vacuum is totally useless. We've gathered mountains of data across 18 complex evaluation areas, but to make it actually useful, the framework mandates that reporting must be treated as an opportunity to document lessons learned and openly share these comprehensive insights. By standardizing exactly how we report these findings, the evaluation results become infinitely more useful for everyone, from the public policymakers designing our city streets to the private sector engineers refining the actual vehicle software. And I think this quote perfectly summarizes the ultimate goal of this entire 200-page framework. The master plan isn't just about ensuring a self-driving car can pass some basic driving test without crashing. The objective is to ensure that the deployment of automated mobility actively and tangibly maximizes societal benefits. It's really about designing a future where transportation is safer, cleaner, fairer, and far more efficient for everyone, not just the people lucky enough to be sitting inside the automated cars. We've covered a tremendous amount of ground today, from individual lines of software code all the way up to the structural fairness of society. But as we wrap up this explainer, I want to leave you with a thought to really chew on. When you look out your window today, at your own streets, your own neighborhood, consider those 4 levels of ripples we talked about. How will autonomous vehicles reshape your own community? Are they going to actually improve your quality of life, or are they just going to add to the noise? The blueprint is written, folks, and the vehicles are absolutely coming. Now it's up to us to make sure we evaluate them the right way. Thank you so much for joining me today, and keep learning.